Have you ever looked around at, everything humans have built, our cities, technology, even abstract stuff like laws, and just thought, why us?
Hmm.
I mean, there's so much intelligence out there in the animal world. Why haven't gorillas, I don't know, built particle accelerators? Or capuchins launched monkeys to the moon? What makes our culture so complex, so cumulative?
It's a huge question, really.
Mm-hmm.
We sort of take our culture for granted, don't we? But from an evolutionary standpoint, it's just completely unique. Really stands out.
And that massive question is exactly what we're diving into today. We're digging into the whole journey of human cultural evolution. We've sifted through quite a stack of sources for this one.
There's a lot here.
We've got mathematical models, theoretical work, some really surprising experiments, people like Magnus Enquist and his team, Hannah Lewis, Laurel Fogarty, and Pontus Strimling doing modeling, and then this key experiment by Lewis Dean.
Right. And our goal, really, is to try and pin down what was different about our ancestors. What specific things allowed our technology, our culture, to just take off like it did in this almost explosive way.
Okay, so let's start peeling back the layers. The first puzzle, as you said, why us? We know lots of primates learn from each other, this cultural drive idea, but humans are just on another level.
Totally different scale.
So what is it? Some people just say, oh, it was luck, sheer chance, one species just got cognitively lucky and ran away with it. But I don't know, that feels a bit weak, doesn't
It
it?
does feel a bit unsatisfying, yeah. You want to find a specific trait or maybe a combination of traits that really explains it.
Right. And another idea people throw around is demographics. Maybe once our populations got big enough, there was more contact, more exchange, so ideas didn't get lost as easily.
And population size, connectivity, they're definitely important. They support complex culture. But it's not the whole story. Lots of animals live in huge groups. Think about, I don't know, massive herds or schools of fish.
But they haven't invented vaccines.
Exactly. Big social networks only help if the animals can actually generate complex culture in the first place. You need the capability first.
Okay, so if it's not just chance and not just numbers, scientists started looking elsewhere. They turned to mathematical modeling, and this is where it starts getting really interesting.
Yeah, some of the first big clues came from Magnus Enquist and his colleagues over at Stockholm University.
Yeah.
They used math to look at something seemingly simple.
Which was?
How accurately information gets passed along what they call the fidelity of cultural transmission. How does that accuracy affect how long a cultural trait, like a tool-making technique or something, sticks around in a population?
Okay, you'd expect, better copying means it lasts longer. Pretty straightforward.
That's what you'd think. But the relationship they found wasn't just linear. It was surprising. Quite profound, actually.
Oh, so?
The math showed the relationship between how accurately you copy something and how long it lasts isn't just a straight line up. It's acceleratory. It's an exponential curve.
Whoa, okay. Exponential. So what does that mean in practice?
It means even a small increase in how accurately information gets copied can have a massive effect. It can transform a cultural idea from something fleeting, something that disappears quickly, into something that's virtually immortal, as they put it.
Virtually immortal. Wow. Like a whisper suddenly becoming a shout that echoes down through generations.
Exactly. It suddenly makes it last, potentially indefinitely. And this gives some real mathematical weight to an idea the psychologist Michael Tomasello had proposed earlier.
Tomasello, right.
Yeah, he argued more verbally that things unique to humans, like our complex language, our tendency to actively teach, our ability to imitate really well, lead to this super high fidelity. And that's what explains cumulative culture, what he called the ratchet effect, in humans but not other animals.
Okay, I think I'm following. Higher fidelity, things last longer. But hang on. If everyone is just copying perfectly, wouldn't that lead to stagnation? Like, where does the new stuff come from if it's all just perfect copies?
That's a great question, and it seems like a paradox at first. But Enquist's analysis sorted this out. The key insight is that when cultural traits stick around for a really, really long time because of high fidelity,
Okay.
that creates more opportunities for improvements, for refinements, for new combinations to happen. A specific idea or technique has to be around, stable in the population, for people to tinker with it, improve it, maybe combine it with something else.
I see. So persistence allows for innovation. It's not that perfect copying stops change, it's that it preserves the foundation for change.
Exactly. It means way more cultural knowledge gets preserved and built upon than you'd ever get with low-fidelity copying.
And you see that contrast in animals, right? Most animal social learning is like pretty lo-fi.
Yeah, very much so.
Yeah.
Often it's things like local enhancement. One animal sees another getting food somewhere, so it goes to that place, but doesn't necessarily learn how the first one got the food.
Right, just drawn to the spot.
Or stimulus enhancement, where attention is drawn to an object. It's more about guiding attention than transmitting detailed skills. And this leads to what researchers call lightning traditions.
Lightning traditions.
Yeah, behaviors that pop up and then disappear pretty quickly, gone in a flash, like
Sure.
lightning.
Okay, but what about chimps? They seem a bit different. They have tool use traditions that last.
They do.
Yeah.
Chimpanzees are a good example of something more nuanced. They can achieve higher fidelity through imitation, copying the actual actions, or emulation, figuring out how to get the same result. And you see the effect.
Like nut cracking.
Exactly. Nut cracking is a classic example.
Mhm.
These traditions can last for decades. Scientists have documented, I think it's around 39 different customary behaviors across chimp groups. But humans, well, with teaching, language, writing, we have the highest fidelity mechanisms by far.
Mm.
And that's why our culture is just so vast and long-lasting compared to theirs.
So chimps are maybe like masters of a few specific long-lasting crafts. But we humans, with our super fidelity, we're building these massive, interconnected libraries of knowledge that just keep growing.
That's a good way to put it. And think about it in larger populations. This fidelity effect gets magnified.
Yeah.
A small edge in copying accuracy scaled up across millions of interconnected people leads to these huge qualitative differences. It really snowballs.
Okay, that exponential curve idea from Enquist is powerful. But, showing the exact link between that high fidelity and cumulative culture,
Yeah.
the buildup needed more proof, right?
It did. It made intuitive sense. But really nailing down how high fidelity leads to accumulation needed more rigorous testing. And that's where Hannah Lewis's work comes in. She built a mathematical model specifically to tackle that.
Okay, so what did her model do?
She basically set up a system where cultural traits could be invented, combined with others, modified, or lost. And she could systematically tweak the rates of each of these things to see how they affected the buildup of complex cumulative culture.
And the results. What popped out as most important?
The results were incredibly clear, actually. By far, the single most important factor was the trait loss rate, which is basically just the flip side of fidelity, how quickly things are forgotten or lost.
Wow. So not innovation, but loss.
Yes. If the transmission fidelity is too low, meaning the loss rate is too high, cumulative culture just cannot get started. Doesn't matter how much new invention is happening, nothing sticks around long enough to build upon.
That's huge. So small improvements in accuracy and just not losing information lead to these big jumps in cultural complexity. Preventing forgetting is almost more important than inventing new things.
In the initial stages, absolutely. You need that foundation of stability first.
Which kind of challenges that whole lone genius idea we have about invention, doesn't it? Because her model suggested most progress comes from tinkering with existing stuff.
Exactly. And that was the other really surprising twist in her findings. Once you have high fidelity transmission in place, keeping ideas around, the factor that then has the biggest impact on driving cumulative culture forward is the rate of trait combination, taking existing ideas and putting them together in new ways.
So remixing and combining beats brand new invention.
In her model, yes, novel invention, creating something totally from scratch, actually had the least impact on the overall accumulation of culture. It suggests human progress is much more about cleverly reworking and combining existing technologies and ideas than it is about these bolts from the blue, these heroic inventions.
It really clicks when you think about it. So much innovation is building on what came before. Okay, so if high fidelity is the absolute key, the foundation, how do we achieve it? You mentioned language, obviously, but also teaching.
Right? Teaching is a huge part of this high fidelity package for humans. And understanding teaching in the broader animal kingdom became really important.
How do you even define teaching in animals? It seems tricky.
It was tricky. But a big step forward came in 1992 when Tim Caro and Mark Hauser proposed a functional definition. They said basically an animal teaches if it changes its behavior only when a naive individual, a learner, is watching.
Okay.
This change costs the teacher something: time, energy, risk.
Right.
And because of the teacher's behavior, the pupil learns something faster or earlier, or maybe learn something you wouldn't have learned at all. It focuses on observable actions and outcomes.
Got it.
Yeah.
Makes sense. Are there good examples?
Oh, yeah. Some fantastic ones. Meerkats are a classic. The helpers, the adults, gradually introduce the pups to dangerous prey like scorpions.
Scorpions!
Seriously.
Yep, they'll start by giving the pups dead scorpions, or ones with the sting removed. Then as the pups get older and better, they give them more intact, dangerous ones. And they actually adjust what they offer based on the pups' begging calls, which indicate age.
Wow. And that costs the adults. It does. They spend time monitoring. They might lose the prey themselves. But the pups get crucial practice they couldn't get otherwise, and they become self-sufficient feeders much faster, which ultimately benefits the group.
Okay, that's pretty convincing. Any others?
Another great one is tandem running in certain ants. When an ant finds a new food source or nest site, it can lead another ant there. The leader slows way down, like takes 4 times longer than usual to get there.
4 times longer. Why so slow?
To allow the follower to keep up, learning the route using antenna taps for guidance. The leader could just carry the follower, which is faster, but carrying doesn't teach the route. Tandem running is slower, costly for the leader, but it ensures the follower learns. Clear teaching.
Orcats. Ants.
Yes.
That's fascinating. But hang on, here's the weird part you mentioned earlier. We see this clear teaching in meerkats, ants, some bees, certain birds, but apparently not in chimpanzees, or dolphins,
Right.
or elephants. The animals we usually think of as super intelligent.
Exactly. That was the big puzzle. Why would these incredibly smart, socially complex animals that learn all sorts of difficult things, seemingly not engage in active teaching? It seems counterintuitive.
Yeah, really. So how did researchers tackle that?
This led Laurel Fogarty and Pontus Trimling to develop another mathematical model, this time specifically looking at the conditions under which natural selection would favor the evolution of teaching.
Okay, what did they find?
Well, some findings were pretty intuitive, like teaching is more likely to evolve if the teacher and student are closely related. Kin selection, basically. Makes sense. Helping your relatives helps pass on shared genes.
Sure.
And obviously, the higher the cost of teaching, the less likely it is to be favored. Also makes sense.
Right, standard evolutionary trade-offs. But was there anything less obvious?
Yes. The really crucial, less intuitive finding had to do with the difficulty of the skill being learned. They found this interesting N-shaped curve.
N-shaped, what does that mean?
It means teaching is not favored for skills that are really easy to learn. If a youngster can pick it up easily through trial and error, or just by watching casually, there's no strong selection pressure for adults to invest costly time and energy in actively teaching it.
Okay. So if it's simple, why bother teaching?
Exactly. And this might explain the chimpanzee situation. Chimps are really good individual learners. Their young often manage to pick up complex skills like nutcracking just by observing and persistent practice over years. So for chimps, the benefit of active teaching might not outweigh the cost. The youngsters get there anyway.
So paradoxically, being a good learner might make teaching less likely to evolve in a species.
Precisely. The better the pupil is at learning independently, the harder it is for teaching to gain an evolutionary foothold.
Okay, that's one side of the end. What about the other? Skills that are really hard.
Teaching is also not favored for skills that are extremely difficult.
If a skill is so hard that very few individuals ever master it, there just aren't enough potential teachers around for teaching to become widespread or effective. There's no reliable skill base to pass on.
So not too easy, not too hard.
Exactly. The sweet spot for teaching to evolve, according to the model, is for skills of intermediate difficulty. Things that are hard enough that they aren't easily picked up alone, but not so hard that nobody learns them. And critically, these skills also need to be valuable. They need to provide a real fitness benefit.
That intermediate difficulty idea, that makes a lot of sense. It explains why teaching seems relatively rare in nature. It requires this specific set of conditions.
It does. It provides a strong explanation for the pattern we see.
Okay, but then there's us, humans. We seem to break all the rules. We teach incredibly complex things like calculus or quantum physics, often people we're not related to, sometimes skills with no obvious direct survival link like, I don't know, playing the violin or tango dancing. How does the model explain that? That was the next big hurdle. How do humans fit in? The key insight came when Fogarty, Strimling, and Enquist extended the model to include something crucial: cumulative knowledge gain. The possibility that knowledge could build up in the population over generations.
Connecting it back to cumulative culture.
Exactly. The hypothesis was, maybe our general ability and propensity to teach actually co-evolved with our ability to build up cumulative culture.
And what did the extended model show?
A resounding yes. When you allow for knowledge to accumulate over time, it makes teaching much more profitable and much more likely to evolve. Why? because knowledge that might have been incredibly difficult for one person to figure out from scratch gradually accrues in the population.
So stuff that was once too difficult becomes more widespread, more available for teaching.
Precisely. Complex information becomes common knowledge, available for tutors to pass on. This creates a positive feedback loop.
Mutual reinforcement.
Exactly. High-fidelity transmission allows culture to accumulate. Accumulated culture makes teaching more valuable and feasible. More teaching further boosts fidelity and accumulation. They drive each other forward. Human teaching and cumulative culture likely evolve together, hand in hand.
That's a powerful idea. It connects everything together.
And there's another piece that fits nicely here. Cooperative breeding.
How does that link in?
Think about the species where we do see clear teaching. Meerkats, ants, bees, some birds like pied babblers, and humans. What do many of them have in common?
They help raise offspring that aren't their own.
Right. Cooperative breeding. Helpers care for others young. This social system seems to lower the per-person cost of teaching. If the burdens of feeding and protecting the young are shared across a group.
Then the extra cost of spending some time teaching becomes more affordable for any one individual.
Exactly. It makes teaching more economical. And this is especially relevant for humans, given our incredibly long childhoods and juvenile dependency. Cooperative care might have been a crucial pre-adaptation that helped make our extensive teaching possible.
Okay, so we have these compelling models suggesting fidelity is key, loss rate is critical, combination drives innovation, and teaching co-evolved with cumulative culture, possibly facilitated by cooperative breeding. That's a lot of theory. Was there experimental evidence to back this up?
There was. And a really elegant piece of work that ties many of these threads together is an experimental study led by Louis Dean, published in Science.
Okay, tell me about it.
They designed this ingenious device, a puzzle box. It was basically a simulated foraging task, but built in 3 stages. To solve stage 1, you got a small reward. But solving stage 1 revealed the bits needed for stage 2, which gave a medium reward. And solving stage 2 opened up stage 3 for the biggest reward.
So you had to build on previous solutions. Truly cumulative.
Exactly. You couldn't skip steps. And they gave appropriately scaled versions of this box to different groups. 3 to 4-year-old human children, chimpanzees, and capuchin monkeys.
And the goal was?
2 main things. First, simply, could these different species achieve cumulative cultural learning on this task? Could the solution spread and build up within the groups? And second, if not, why not? Could they test some of these competing ideas about fidelity, teaching, social factors?
Okay, the moment of truth. What happened?
The results were incredibly stark. For the chimpanzees and capuchins, there was very, very limited success. Across all the chimp groups, only one single chimpanzee managed to reach stage 3.
1 out of how many?
Out of 33 chimps who participated. And even when they put trained demonstrators in the groups, chimps who knew the solution and performed it repeatedly, that knowledge just didn't spread effectively to others.
Wow. And the capuchins.
Similar story. Very little progress beyond the first simplest stage. They basically interacted with the box, but mostly in a self-serving way, trying to get rewards directly, not really learning the sequential solutions or helping others learn.
Okay, so not much cumulative culture there. What about the kids?
Completely different picture. Strikingly different. Even though the children had much less time with the box, only about 2.5 hours compared to over 30 or even 50 hours for the primates. Most groups of children had multiple individuals reaching the final 3rd stage. It was clear, unambiguous evidence of cumulative cultural learning happening right there in the experiment. The solutions were spreading and building.
Okay, that's a massive difference. So why? What were the children doing that the chimps and capuchins weren't? What explained their success?
It really came down to what the researchers called a whole package of social cognitive abilities that the children deployed, which were absent or very rare in the primates.
Like what? What was in the package?
First and foremost, teaching. The researchers observed 23 clear, unambiguous instances of direct instruction. Things like kids saying, push that bit there, or pointing, or physically guiding another child's hand.
And this only happened with the children?
Only in the children. And crucially, the children who received verbal instruction were significantly more likely to succeed. The chimps and capuchins showed basically 0 behaviors that looked like teaching, not even simpler teaching precursors.
Incredible. So direct, active teaching, especially using language, was a game changer. What else?
Imitation. The children performed significantly more actions that were clear copies or matches of what they saw others doing successfully. They were actively trying to replicate the specific actions, showing higher fidelity imitation.
Okay, teaching, imitation,
Yeah.
anything else?
Yes, and this one is really fascinating. Prosociality and cooperation. The researchers recorded 215 instances where children spontaneously gave the reward stickers they earned to other children in their group.
They just gave them away
Yeah.
altruistically.
Yes. 215 times. This kind of voluntary resource donation was completely absent in the chimps and capuchins. The children seemed to approach the task more cooperatively, understanding shared goals, helping each other out. The primates were much more individualistic and competitive around the box.
Wow. So it's teaching, imitation, and this general pro-social cooperative orientation. That's the package.
That seems to be it. And the study looked for other explanations, like maybe the chimp's social structure got in the way, maybe dominant individuals hogged the box, or maybe they just weren't smart enough non-socially. But they found no support for those alternatives.
So the conclusion was pretty clear.
Very clear. The children's success in achieving cumulative culture on this task was strongly linked to this suite of social skills. Teaching, especially verbal, imitation, and pro-sociality. This package seems critical for cultural transmission to ratchet up effectively.
So bringing it all together then, the sort of aha moment here, is that this incredible complexity of human culture we started with, it doesn't just hinge on us being generally smart. It seems to critically depend on these specific social capacities. Our ability to teach, to use language, to share information precisely, to imitate accurately, and maybe even our underlying tendency to cooperate.
That's the core insight, absolutely. And this experimental work provides really strong backing for how and why these abilities are so fundamental to our unique cultural trajectory.
And it explains that paradox we talked about earlier, right? That teaching seems to be both a cause of our complex culture and also a product of it.
Exactly. It sounds circular, but that's precisely what you'd expect if you have a powerful feedback loop operating what some have called the cultural drive. High-fidelity transmission mechanisms like teaching allow cumulative culture to emerge. That accumulated culture then makes teaching even more valuable and likely to evolve, which further enhances fidelity. It's a self-reinforcing cycle.
Okay, so let's recap. We've just unpacked this incredible journey figuring out how human culture got so ridiculously rich and complex. And the answer isn't just big brains. It's really about how we share, preserve, and build upon knowledge.
Right. Specifically through these uniquely high-fidelity mechanisms, teaching, language-based instruction, accurate imitation, all fueled by an underlying pro-sociality and cooperation.
It really highlights that our ability to teach, to actually go out of our way, often at a cost, to help someone else learn, isn't just some, nice little feature of human society. It's fundamental. It's a pillar that allowed our knowledge to become, as Inquis put it, virtually immortal and to ratchet up into this complex world we live in.
It underpins so much of what makes us human.
So here's a thought to leave everyone with. If our incredibly complex culture relies so heavily on this evolved capacity for teaching, this high-fidelity transmission, what happens now? We live in this age of insane information density, but maybe less direct, person-to-person teaching in some ways. How might our digital ways of sharing information, wikis, forums, AI tutors even, how might they be reshaping that delicate, evolved balance between fidelity, innovation, loss, and accumulation? Are we amplifying the ratchet or maybe changing it in ways we don't fully understand yet?
That's a really interesting question for the future, isn't it? How these new transmission mechanisms interact with our evolved